Now we're working on the amplifier module, and we're replacing all the capacitors except for the silver mica capacitors. Because of the materials used on a silver mica capacitor, it's not really necessary to replace it because they don't dry out like the wax capacitors and the metal ones do. Also, we're going to test the resistors. Sometimes the value of the resistor can increase after a certain age, so we need to check that too. So this one here, which is a 27K, we need to check. So we put the ohm meter across there, and as you can see, that one has actually gone high. It's gone up to 330K, which is well out of tolerance. So we're going to replace that, and here's a new one. And if we put the multimeter across, as you can see, that comes to 268, which is well within the 5% tolerance. So we desolder the other one. It should just come out like so. While we're at it, we'll test this resistor here, which should be 120K. That looks like quite a high wattage one. What we sometimes need to do is just desolder them one end, because there may be resistance in other parts of the circuit. Now this one here should be 120K. Whoops. Sorry, 100K. And that's 99K. So that's well within the tolerance. Solder this one back. And we need to do this working our way along the boards, this tag strip here, replacing any resistors or capacitors. Now we come to a capacitor which will almost definitely need changing. That's a 0.1. It's important to replace these capacitors with the correct working voltage. Otherwise they'll fail very quickly. This capacitor here we're going to replace with an LCR capacitor. So that's a 0.1, and the working voltage of this capacitor is 1000 volts, so that'd be more than adequate. We also need to replace a resistor here too. LCR capacitor there. So we'll solder up that end. One thing I've noticed is all the high wattage resistors look pretty good to me. It's the lower wattage resistors that are ones that need replacing. This capacitor at the end here, which is a mustard capacitor, I'm very tempted to not replace that one because these are good quality capacitors and they don't wear out as quick as other types. This has obviously been replaced sometime more recently. So that's the first board done. Now we've replaced quite a few of the resistors, we now want to look at replacing the CAN type electrolytic capacitors. I think we can see one here. What we're going to try and do is keep the CAN and build the new smaller capacitors into the old CAN, and that way it won't detract from the appearance of the amplifier module. So first we're going to disconnect a lead to it. We've made a note on here of the red tag and the yellow tag, which has two different values. This CAN is two capacitors, two electrolytic capacitors in one. So next we need to just undo this one. Just a clamp, and that should come away. Get the screwdriver in there. Yep, loosen it off. And we should just be able to pull it out. There we go. And as you can see, it's got a resistor across it, so we need to test that resistor too. Problem now is getting the actual capacitor out, so we're going to have to cut it with a knife. I'm going to be very careful so I don't cut my fingers too. I have to put quite a lot of pressure on this to cut it. There we go, that's the rubber coming off. It's all coming out. Just got to do it bit by bit without damaging the body of the capacitor too much. And here we have it. Definitely looks like this capacitor has seen better days. What we're going to do here is put two smaller capacitors inside. Not smaller in value, but smaller physically sized. Now we've replaced most of the resistors on the amplifier. There's a few we don't actually have in stock, so we'll have to order them. These jack sockets on the front often need cleaning up, so just take this off here. Being careful not to lose the washer. And just re-burnish it with a piece of fine emery cloth. These tend to get very dirty after a while, so we do them. And they also tend to lose their springiness, so we just push them back just a little bit. So they make a good contact with the jack plug when it goes in. Okay, we got to the stage now where the main bit of the amplifier is now rebuilt. And you have mostly new resistors and capacitors. The electrolytics have been repaired by putting smaller ones, same value, same voltage, but some physically smaller ones in the cans. Also, the bias oscillator and the power supply has now been rebuilt, and as you can see, we've got new capacitors and resistors and the electrolytics on here. We're now ready to put the valves back in the amplifier. So what we're going to do is just spray a bit of contact cleaner in the sockets to ensure the valves will make good contact. So we start here with this one, which is the main output valve, and that's a pentode, and it's an EL84. So it goes in there like so. And then we have an ECC83. This controls the actual meter. That goes in there and that clips on top of it like so. And the F86, that's going to be a preamplifier valve. And again, it's a shielded pentode. One just plugs in there like so. There are two more EF86s, and these are shielded by a can that goes on the outside to stop any electromagnetic interference. These are in the first stages of the preamp. Let's just give it a bit of a squirt first, so they all make good contact. These also have a sort of rubber base, because these valves have sort of microphonic tendencies. That means to say if you tap them, they'll pick up the noise. So effectively the valve acts a bit like a microphone. So that's that one now. And the can to go over the top. And the last one there. And then again, that fits over there like that.